this problem, they ask you 6 different limits value. The first three here, x approaches -3. So we target -3. Okay, -3. Where is -3? This is x, right? X value. The x, look at the x direction. Where is x? -3 right there. And the next 3 target the number 1. So x approaches 1. Where's the number 1? 1 is over here. Do one at a time. What's the difference among the first 3 limit values here? The part A, this is the left hand limit. Why left hand? Because superscript negative sign. Second one, that's the right hand limit. The last one, they call two-sided limit because no superscript. Okay, similar to the next 3 limit problems there. Target number 1, but look from the left to the part D is the left-sided limit. Next, this is the right-sided limit, and the last is two-sided because we do not see superscript above on the upper right corner of number 1. All right, one at a time. For A, B, and C, the left-hand limit. Since we target number -3, right? -3. The left side, how do we find the limit value? Using the graph. For the left side, you trace the left side of the x equals -3 graph. See, do you have this portion, right? When you walk along the graph or you move along the graph here toward to the spot where x equals -3, what would be the function value? Anyone?
5.
5. So the left-sided limit as x approaches -3 gonna be 5. All right. Next one. Same target like x
I'm sorry.
-3. Yes.
Why is it 5?
Because we aim at x approaching -3, correct? X -3. And the superscript negative side there that tell you is the left hand limit. And that means you look at the graph, which is the graph of the function. You have 2 portions here, the left side, the right side.
Right.
It asks for the left hand limit. You trace along the left part of the graph. And when you move along the graph, it's coming toward to what value of the function? That's the question that you could ask yourself. And that's the number of the function that it's approaching to.
Okay, got it. Yeah.
Okay, good. Anyone has other questions? Okay, so that's the left part. How about the right part? Can you guys tell me or type in the chat? What the value of the right-sided limit?
6.
It's going to be 6. Everyone agree?
Yeah. Can you walk us through how you got 6 again? I was tracking in the other one. I'm gonna have to watch how you do this one.
Okay, so no problem. So as you see, you guys okay with the 5, right? Your target is -3, that's what we target. And then when you see superscript left, negative sign, we go to the left. So that's why we get the answer 5 for part A. And then for part B, from the right, so this time we're gonna look at the right side of the curve that coming toward to when x approaches -3. And the curve approaching to the empty dot here. Do not worry about the empty dot. We just look at the value of the function when it's approaching to the empty dot. And for the right side limit, as x approaches -3, gonna be 6. That's why the answer is 6 for part B.
Okay.
overall, you look at the value of the function from when you move from the left side or you move from the right side. So the superscript negative side, you look for the left part of the graph. Superscript positive side, you look at the right side of the graph. Okay. And then the last one, I mean, not the last one yet, but part C, no superscript. That means you look at the two-sided. So for this case, the left side goes to 5, the right side goes to 6. They are not the same. In this case, they don't agree to come to the same target. If they don't agree to come to the same target, the two-sided limit does not exist. Okay, and the short term is DNE, from does not exist. And from the graph, you can see that the graph is broken because one approaching to one number and the other part of the graph approaching to different number. So the graph is not connected, or the graph has a jump, okay? You guys good? Yes?
So if it was connected, would it be just the y value of where the dots connect?
The dot, yes. It could be connected with the solid dot or the empty dot, as long as they come toward to the same number.
Okay, thank you.
Okay, you're welcome. And then the next three, the three parts here are gonna help you put pieces together more. Let me clean up some. Okay, so work ready to go. Okay, for the D, E, and F, we target X approaches -1 this time. Oh, X approaches 1 equals 1. Okay, now part D, coming from the left because superscript negative side, we look at the left part of the graph. Think about the trend of the graph. What would be the function that it's coming toward to? The value would be 2, correct? Right?
Yes.
Okay. And then same thing, you look at the right part of the graph because the superscript positive side. So walking toward to exactly the same number 2. Now they go to the same target. In this case, these two numbers equal to each other. Therefore, part F, no superscript, it's understood to be two-sided limit. That means two sides have to agree to come to the same number. And this situation, yes, they come to the same number too. You see two different situations. As X approaches -3, this is jump, so no limit, or we call it does not exist. But for the case that X approaches 1, they both come toward to the same number. So then we can say that common number is the two-sided limit as X approaches to the number 1.